we take force horizontal to the plane of motion. Now we consider one, body held at rest on plane by external force P horizontal to the plane. Now we can draw the incline, right? And then we consider a body. On the incline. Normally, the normal reaction would be like this. Okay? The weight will be acting downwards. Are we there? Now, the incline is at an angle theta. Of course, this angle will be theta also. Alright? Now, if we resolve the component of the weight parallel to the plane and vertical to the plane, we have W sine theta, and we have this side W cos theta. Are we there? Normally, if we allow this body, it will slide downwards. So the frictional force will be acting upwards. Let's call it mu Rn. Are we there? Now, if you consider a horizontal force P this way, right? Let's call it P. Okay? Acting horizontally, holding this body up the incline. Of course, if we resolve this horizontal force, we have it this way. Let's say I bring it down, right? Then I take this. Are we there? So I'll have, of course, this angle is theta, right? Now, if we resolve this P vertical, it will be what? P sine theta. And then mark you, this component will be P cos theta. By far, these are the forces acting on this body as a result of the horizontal force P. Now, assuming we resolve the system of forces, let's say in the horizontal direction, we'll have what? W sine theta, pulling it towards the left, is equals to what? Mu Rn plus what? P cos theta. Let's call this equation number 1. Are we there? Now, let's resolve the system of forces vertical to the plane. What will we have? We will have Rn, that's the normal reaction acting upwards, is equals to what? We have W cos theta acting downwards plus P sine theta plus P sine theta. Alright? Acting downwards. That means the normal reaction is acting upwards. It's being balanced by W cos theta acting downwards plus P sine theta. Let's call this equation number 2. Are we together? Now, supposing we solve equation 2 in equation 1, that is sub 2 in 1. I'll be having W sine theta is equals to mu. What is our mu Rn? What is our Rn? Rn is what? W cos theta plus P sine theta. Are we there? Alright? Then plus P cos theta plus P cos theta. Are we together? Now, we know that W sine theta is equal to what? Now, what is mu? Mu is equal to what? Tangent phi. And tangent phi is what? Equal to what? Sine phi all over what? Cos phi is the angle of friction. Right? This is equals to, we open the bracket W cos theta plus P sin theta. Are we there? Plus what? Plus P cos theta. Are we there? Now let's transfer P cos theta on the right hand side to the left hand side. I will be having W sin theta minus P cos theta is equal to what? Sin phi all over what? Cos phi. Are we there? Then we can put in the bracket W cos theta plus what? P sin theta. Are we together? Now we can cross multiply by multiplying the left hand side by this cos phi. Are we there? Let's see how this pans out. Now cos phi, that is, we cross multiply this. We open a bracket. Are we there? Put in W sin theta minus P cos theta. W sin theta minus P cos theta. P cos theta. Now I close the bracket like this. Equals to sin phi. Equals to sin phi. Open bracket. W cos theta. Right? W cos theta plus P sin theta plus P sin theta. Are we together? Now let's open up the bracket. I'll have W sin theta cos phi, right? Minus P cos theta cos what? Cos phi, right? Equals to W cos theta, W cos theta sin phi, right? Plus what? P sin theta, P sin theta sin phi. That's great. Okay, we have W sin theta cos phi minus P cos theta cos phi equals to W cos theta sin phi plus P sin theta sin phi. Now let's bring the P terms together and put the W signs together. Now if I bring this, no, let me take this to that side, right? And then bring this W cos theta back to this side. So I'll be having W sin theta cos phi minus W cos theta sin phi. And this, I take this to this side. Is equals to P sin theta sin phi. As I take this to that side, it becomes plus P cos theta, P cos theta cos phi, cos phi. Are we there? Now we can factorize and take in the W signs outwards. I'll have W open bracket sin theta cos phi minus cos theta sin phi, right? Equals what? P open bracket sin theta, let's say sin phi plus, let me put here, plus cos theta cos phi. Sorry. Now if I close my bracket like this, alright? Let me make P the subject of this formula. So P is equals to W open bracket sin theta cos phi minus cos theta sin phi all over what? all over sine theta, sine theta, sine theta, sine phi plus what? Cos theta, cos phi. Are we there? We have P is equal to W, open bracket, sine theta cos phi minus cos theta sine phi all over open bracket sine theta sine phi plus cos theta cos phi. Normally, when you get to this side, you make use of the compound and multiple angles. Now in compound and multiple angles, we have sine open bracket A plus B close the bracket is equal to sine A cos B plus cos A sine B. Now this means that I will have P is equal to W sine theta. P is equal to W, then sine open bracket theta minus phi, all right, all over cos open bracket theta minus phi. Are we there? Now, of course, we know that sine upon cos gives us tan. Therefore, we have P is equal to W tan open bracket theta minus phi. All right. Now, this is the force required to hold a body up an incline of theta when the angle of friction is phi. And the horizontal force P required will be P is equal to W tangent theta minus phi. To show that the horizontal force required to hold a body up a plane is given by P is equal to W tangent theta minus phi. Now we are considering case 2, direction of motion up the plane. Now the hauling force P horizontal to the plane. Now if I draw the plane, the inclined plane dots, and I put a body on top, the incline is at angle theta. Often the normal reaction acting upwards. Are we there? The weight acting downwards. W. The component of the weight parallel to the plane, that is W sine theta. Mark you, this angle is also theta, right? And the components of the weight acting downwards as W cos theta. Are we there? Now, the horizontal force P, just like the one holding it up, is acting horizontal. Let's call it force P. Are we there? Now, if the body tends to go upwards, the force of friction will be acting towards the left in opposition to the direction of motion. Now, if I put the frictional force as mu Rn, are we there? Of course, we can resolve this horizontal force P into two component directions. Now, horizontal direction, right, and the vertical direction. Okay, again, the angle here is theta. All right, I will have the component, vertical component downwards as what? P sine theta, and the component of the horizontal component of P acting upwards will be P cos theta. By far, these are the forces acting on this body. Now, by similar analysis to the one earlier taken, we'll find out that the force required to hold a body or to hold a body up an incline of theta when the angle of friction is phi, it will be P is equal to W tangent, we have theta plus phi. theta plus what? Plus 5. Are we there? And then the last of these forces will be the force, horizontal force, required to haul the body down the incline. We take direction of motion down the plane, hauling force P horizontal to the plane. Now, if I draw the inclined plane this way, and I put the body like this, right? Normal reaction, Rn, the weight acting downwards, which is W. The component of the weight parallel to the plane, I put it W sine theta. The angle of the plane is theta always, and then this angle is also theta. Now, the vertical component of the weight will be W cos theta. Now, mind you, this time the horizontal force P is acting down the plane. Now, let's call it P, alright? P. Okay? Now, since the direction of motion is down the plane, the force of friction will act upwards in opposition to the direction of motion, which will be mu Rn. Now, the next thing is to resolve this force P. Now, resolve them into component directions, horizontal and vertical. Now, I call the vertical P sine theta, and I call the horizontal P cos theta. Are we there? Therefore, this is the force diagram for the horizontal force P required to pull a body up an incline of angle theta when the angle of friction is theta. Now, found out that by similar analysis, we have P is equals to W tangent, we have phi minus theta. Most students have difficulties with the drawing of the plane. Are we there? But I have taken my time to resolve these forces so that if you know the analysis will follow, you won't have much problems.